So nothing's canceling, so no holes. Our vertical asymptote happens when the bottom equals 0, so when x is -1, our function blows up. Our horizontal asymptote, the bottom has x squared and the top has only an x to the first, so since the bottom is bigger, it's going to be y equals 0. I'm going to check to see if it ever crosses the horizontal. So I'm going to check to see whether my function, x minus 2 over x plus 1 squared, ever equals whatever I got for my horizontal asymptote, in this case 0. So if I cross multiply, I'm going to get x minus 2 equals 0, and it will cross. It will cross the horizontal when x is 2. Okay. Good to know. And so now we just keep going. I'm going to go ahead and get an x-intercept. I'll get the y-intercept first, it's easier. So the y-intercept always happens when the x is 0. So when the x is 0, I'll have 0 minus 2. So y will equal 0 minus 2 over 0 plus 1 squared. So that'll be -2 over 1, so just -2. And then the x-intercept will happen when the y is 0. So this is the y equals, right? So 0 will equal x minus 2 over x plus 1 squared. Cross multiply, x minus 2 equals 0. Yes, we already solved this. It's the same place where the horizontal crosses. So, okay, that's fine. So we'll plot what we've got. We have a vertical asymptote of x equals -1. We've got a horizontal at 0. We know it crosses when x is 2. So right there, it'll cross this horizontal asymptote when x is 2. I have a y-intercept of 0, -2. And turns out I would have been okay because the x-intercept would have been 2 anyway, and I would be like, oh, look, it crosses. The interesting thing that I should have pointed out earlier is that this vertical asymptote has a power of, came from a factor with a power of 2. So that means, I'll put a star over that asymptote, that's always, because it's squared, it's not going to change signs from one side to the other. It doesn't matter whether we go a little bit to the left of -1 or a little bit to the right of -1. -1.1 plus 1, doesn't matter whether it's positive or negative, when it's squared, it'll be positive no matter what. So this expression is not affecting whether this function is positive or negative, it's just the top that's controlling it. So whatever it is on one side of the asymptote, it'll be the same thing on the other. So what I mean by that is I've got a couple points to get me started, and since I'm down here, and I know that this is the only place where I can cross this asymptote, I can safely say that I'm going to come down here, hug my asymptote there, go through, cross through there, and then come back down to hug the asymptote. And I know I crossed through because that x minus 2 came from something with the power of 1, so it's not going to jump back down. If it jumped back down, that would be problematic because eventually I need to get, well, no, I'd be able to get back to here anyway, but eventually when x is infinity, I need to come back and hug the horizontal. So it's kind of funky over here, but that's okay. So that's what it's doing on this side of the vertical asymptote. On this side, hey, I remember I put a star over that. That means that going on either side of this vertical asymptote, it's not going to change signs like it usually does. If it's negative over on this side, it's going to stay negative over on that side. So I'm negative down here, hugging that horizontal vertical asymptote, because I can speak. And because I know I never cross this, I am safe to go like that. And we've graphed so many of these, we know this is the basic shape. Of course, you can always plot points if you want, but this is basically what it's going to look like. Ta-da!